So, how do you actually build an AI team that learns? I don't just mean a bunch of smart models working side by side. I mean a real, cohesive team. One that remembers its decisions, learns from its mistakes, and builds a shared history over time. Well, this is the story of how a team of researchers accidentally built a team of AIs with total amnesia. And in the process of fixing it, they stumbled upon a whole new way of thinking about AI memory.
Okay, let's just start with this, because this one sentence from the researchers really captures the entire bizarre journey. It's a huge clue that something really weird, something deeply counterintuitive is going on when we try to give AI a memory. And, it points to one of the most dangerous and, frankly, invisible ways these systems can fail today.
All right, so this whole thing kicked off, not with a memory system, but with a team of 8 specialized AI agents. You had an infrastructure agent for the servers, a marketing agent writing copy, a QA agent testing code. You get the picture. They were all brilliant specialists, for sure. But as a team, they had complete and total amnesia.
I mean, just imagine coming into work every single day and it's your first day on the job. That was literally the reality for this AI team. Every single session was a clean slate. Any decision they made yesterday? Gone. Lessons learned the hard way? Vanished. Progress was just impossible because the team had no continuity, no shared history, no collective sense of purpose.
So the solution they came up with wasn't some fancy high-tech vector database or a super complex retrieval algorithm. Nope. It was something so straightforward they actually called it poor man's memory, or PMM. And its real power comes from this fundamental shift in how we think about an AI's relationship with knowledge. It's a shift that honestly is almost the opposite of what you'd expect.
And this slide really gets to the heart of that philosophical divide. On one side, you have the way we usually do it, something called retrieval augmented generation, or RAG. It treats the AI like a passive bystander. Some other system finds what it thinks is relevant information and just stuffs it into the AI's context. But with PMM, on the right, the agent becomes an active participant. It knows there's an archive of knowledge, it knows how that archive is structured, and it gets to decide for itself what to go look for.
And here it is, the whole architecture in all its glory. It's just a set of organized markdown files tracked in Git. That's it. You've got a file for decisions, a file for lessons learned, another one for standing instructions that never change. The structure is the search algorithm. The agent doesn't need a fancy index because it knows, hey, if I need to know what we decided last week, I just need to read decisions.md. It's a beautiful, elegant, and just brilliantly simple solution.
So the team gets PMM up and running. The agents seem to be improving, and their performance scores are consistently high. Everything's looking great. But just when they thought they had it all figured out, they noticed this strange pattern, and it led to a shocking discovery. They weren't actually measuring what they thought they were measuring at all.
This was the big question they had to ask themselves. When several of your most experienced, battle-tested agents all get nearly identical high scores, does that really mean they've all hit peak performance? Or does it just mean your test can't tell them apart anymore? How would you even know?
So to test this, they did something pretty radical. They sent in a completely fresh agent. No memory, no history, 0 team knowledge, and they had to do the same tasks. And its score? 0.92. Think about what that means. Their test was only good for one thing, telling them if the base language model was competent. It couldn't tell the difference between a brand new agent and one that had absorbed the wisdom of 87 prior sessions. It was measuring potential, not progress.
But this failure? Well, it actually led them to a massive breakthrough. They realized there's a world of difference between an AI giving a correct answer and an AI giving a correct answer that is consistent with everything the team has ever learned. It's the difference between a talented soloist and a world-class orchestra. And they gave this idea a name, institutional coherence.
This slide just nails the distinction. On the left, you've got model capability. That's about producing one right answer in a vacuum. But over on the right, institutional coherence. That's about producing a correct answer that is grounded in the team's entire history. It's not just about a single data point, it's about being part of a larger story.
And this quote just says it all. It's not enough to be right anymore. The new goal is to be right in a way that aligns with hundreds of previous decisions, lessons, and rules. It's a much deeper, more auditable, and frankly, a much more valuable form of intelligence. And it's a total game changer.
So with this new focus on coherence, how did poor man's memory actually do? Well, the data from their evaluations revealed 2 huge findings. One showed exactly where all the value was coming from, and the other, well, it exposed a really serious hidden danger.
Just look at this breakdown.
Only 17% of the memory's value came from information that was preloaded into the agent's context window. But a whopping 83%, that came from what they call retrieval lift. That's when the agent actively decides to go into the archive and find the information for itself. The value isn't in what you spoon-feed it, it's in what it can hunt down on its own.
But the single most important finding was this hidden danger, a trap they called the partial context trap. And this is where that wild quote from the very beginning comes back into play. It turns out that sometimes giving an AI a little bit of information is far, far worse than giving it none at all.
This is just stunning. On the left, when they preloaded only half an answer into the context window, the agent scored a 0.2. It took that partial information, assumed it was the whole story, and then produced a completely confident but totally wrong answer. It lost its sense of uncertainty. But on the right, when the agent could retrieve the info itself, it found both halves of the answer and scored a perfect 1.0. That difference is a powerful, powerful lesson.
So what does all of this mean for people actually building these systems? Well, this whole journey of discovery really boils down to 3 clear, practical design principles for anyone who wants to build AI teams that can genuinely learn.
First, build an archive, not a cache. Your main goal should be making your team's knowledge easy for the agent to find, not trying to guess what it needs and stuffing it into the context. Remember, the value is in the hunt. Second, you have to tell your agents the memory is there. It sounds so obvious, right? But the magic of autonomous retrieval only works if the agent knows it has an archive it can go and search. And third, you have to test for these invisible failures. That partial context trap is dangerous precisely because the AI's output looks totally fine to a human. You have to hunt for it. You have to be a detective.
And that leads us with this final, really crucial question. The discovery of that broken scorecard forces us to ask, are the tests we're building actually measuring true, institutionally coherent wisdom? Or are we just getting better at building AIs that can give a single, convincingly correct answer? The difference between those two things, well, it might just be everything.